Okay, everybody, welcome back. This is the second video on basic math rules. And in this video, we're going to talk about a couple other concepts. One, we're going to talk about decimals and percents and go over those. You'll be using those a lot in psychometrics. And another thing that you'll be using a lot, the third issue that we'll talk about, or the third concept, is dealing with exponents and roots. And don't worry, we will get through this. It's a kind of a review. You've seen these before, and chances are this is just kind of a refresher for most of you. So hang in there, and we'll get through this really quick together. All right, decimals and percents. Let's talk about that first. One of the rules that you want to understand about decimals is that decimals indicate that part of the number following the decimal point, and that is actually a fraction. The numbers that follow the decimal point are a fraction with 10, 100, 1,000, 10,000, 100,000, and so on. So to describe what I mean by that, if I write the number 3.2, that's a decimal because I have a number to the left, or excuse me, to the right of the decimal place. And that 3.2 is synonymous with 3 2/10. The first number to the right of the decimal place is actually in the 10th place. Okay, and so that can be written as 3 2/10. It's pretty basic. Now, of course, you can reduce this down, which this value here, this can be reduced down to 3 1/5, which is the way you were probably taught to do fraction reduction. But for purposes of this demonstration, I'm going to not do that so that we can focus instead on what this is actually, what decimals mean. Okay, so let me come back over to my pen here. If I increase this then to 3.2, say 3.25, that is also the same thing as 3 25 over 100, because the 5 now is in the 100ths place. It's 10 and then 100. So where the 2 here was in the 10ths place, the 5 is now in the 100ths place. So it's written as 3 25 over 100. And if I add another number to it, and we could keep going on and on and on, but you kind of get the sense, the gist of it after this. If I put, say, let's say 3.257, the 7 is now in the 1,000th place, or thousandths place. So if I write that in a fractional form, it ends up looking like 3 257 all over 1,000. Okay, kind of see how that works. So it's not particularly complicated, but it's important to know that you can go back and forth between decimals and fractions. And this is an important concept that you'll find that you'll use a lot in psychometrics. Okay. All right. One other thing with this is around the issue of what we would call rounding rules. And basically the issue with rounding, let me come back and clear this out here real quick. The issue with rounding is sometimes when you compute a decimal, it just keeps going on and on and on and on. So for example, if I had the number again, 3.257, like we just said a little bit ago, and I wanted to round this up to the 10ths place, So it would be 3 point in just one decimal place instead of 3 decimal places. If I just wanted 1, I would need to round this. And the way this works is if the decimal number to the right of the one you're interested in is less than 0.5 or it's less than 5, you just kind of throw it away and you're kind of done with it. In this case, though, 7 is greater than 0.5. So what we want to do to cut that off is we want to round up the next number of 5, which is going to become 6. So now, get my eraser out here again. Start over here. In this rounding, it's going to become 3.26 to get rid of the 7. Because 7 is greater than 5, it rounds up the number next to it. Again, I was interested in the 10th value in this place, so I'm going to round it up one more time. So 3, the 6 then is greater than 5, so it's going to round up the next number, the number next to it, to 3, and this becomes my answer. So what started as 3.275 here, if I round up to the 10th place or the first decimal place after the whole number, it ends up becoming 3.3. So instead of 3.725, it's 3.3. And that's the rounding rule, which I'm sure, again, you've all heard of. But this is kind of how it works, okay? All right. One other thing with decimals and percents is how to create percents from decimals. And I'll go ahead and just demonstrate that here since we've got some space. If we want to convert from decimal points to percentage rates or to a percent, it's an easy formula to go from a decimal to a percent. So if I have a number such as 0.25 and I want to convert that to a percent, the formula for that is the number times 100. That's going to end up equaling the percent. So 0.25 times 100 equals 25%. So it's pretty basic to go from a decimal place to a percent value. And the same thing could be applied here to the number that we just created, 3.3. 3.3 times 100 ends up creating the percentage amount. And if you'll notice here, it's just moving the decimal place over 2 places. That's all that multiplication is doing. So I could take this and move it over once and twice, and then fill in the hole here, and then remove that. And that's going to be 330%. Excuse me. Erase that. 330%. So percentages are easy to calculate. It's just multiplying the decimal place or the number with the decimal times 100. Okay. All right. So exponents and roots. Let's talk a little bit about that. Let me erase this. All right. Okay. So exponents and roots. The rules here are an exponent. What an exponent is, it's basically it's a small number that is placed slightly higher and to the right of a number or an expression. So for example, 5 to the second power, or 5 squared, has an exponent of 2. So 5 of it has an exponent of 2. Okay. And what this means is, in calculating it, is you're multiplying 5 2 times. So you're taking this number and you're multiplying it twice. Okay. So what that would look like is this: 5 times 5. Of course, that equals 25. So that's 5 squared, or 5 raised to the second power. Okay. Likewise, if you had, say, 10 to the third power, that's going to be the same thing as 10 times 10 times 10. And that is going to equal 1,000. 10 times 10 is 100, times 10 is 1,000. Okay, that's the same thing with variables as well. So if I had x to the fourth power, that's the same thing as x times x times x times x. Okay, so it's pretty basic in terms of what exponents do. Now roots are the inverse of this, or the opposite of exponents. I've heard some people say you can have square roots, for example, which is the opposite of an exponent of 2. Let me demonstrate that for you. Change colors here. All right, so if you have 5 squared, that's 5 times 5, that's going to equal 25. You could say then that the square root, which is basically, it should be written with a 2 inside of the root symbol, but shorthand, anytime there's a square involved, it's usually left blank, but I'll leave the 2 in for now. The square root of 25 then just takes it back in the opposite direction. That ends up being 5. So 2 numbers that multiply together that equal 25. That's what this says. 2 numbers that multiply together that equal 25. And of course, that's 5. All right. So you can have, just for an example, you can have the square root of 9. So 2 numbers that multiply together that equal 9. Of course, that's 3. You could have, let's see, the square root of 36. That's going to equal 6 times 6 is 36. So that's that. But you could also have the cube root of a number. So what that means is 3 numbers that multiply together that equal a value. What is that? So if I had the cube root of 8, for example, what are 3 numbers multiplied together that equal 8? And that turns out to be 2, because 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. So 3 numbers multiplied together that equal 8 are going to be numbers 2. So those are exponents and roots and what that's kind of all about. So next we're going to pick up on, in the next video, orders of computation. And we'll also talk about a concept called summation. And that'll get us going into statistics even more. All right. So I'll see you in the next video.